In the first lesson, we will consider creating a 3D model. The 3D model will be a flange that is included in the assembly of the ball valve. To create a 3D model, we will use a 3D model prototype. There are two prototypes, ISO and ANSI. In this lesson, we will consider creating a 3D model based on the ISO standard prototype. In the window that opens, you see the work planes. The 3D model ribbon tab will also be active. We talked about how to customize filter toolbars, other toolbars, the system interface and how to configure settings and system parameters in previous lessons. Now let's create the model. A 3D model consists of operations, the construction of which is based on the creation of elements such as 3D profiles, 3D paths and other elements. To create 3D profiles, we use workplanes, surfaces, faces of already created geometry. Since there is nothing in the 3D scene, let's use the workplanes. Select the workplane front view with the left mouse button, a dynamic toolbar will appear. You can select a command to draw on the workplane, or you can immediately create two mutually perpendicular lines in the center of the workplane. In T-FLEX CAD, 3D profile creation is based on construction elements and their outline with graphic elements. Accordingly, the base of the 3D profile is first created, after which it is outlined. Created construction lines are fixed by default. This prevents the lines from moving around the plane. If necessary, the fixation can be removed. Now let's create the skeleton of the 3D profile. We must set aside a series of lines to the left from the vertical line and a series of lines upward from the horizontal line. To do this, use the line command, select the vertical line with the left mouse button and enter the value 12.5, 14.4, 15.5, 18.25. As you can see, the input is carried out in the window on the left. It is not necessary to click there, the input is done automatically. Now we will do the same with the horizontal line, select it with left mouse button and enter the value 0.5, 6.7, 11.2. We will have a skeleton 3D profile. The skeleton is stroked with the graphic line command. Choose this command. There are two modes in this command. This is the so-called free entry mode, when you simply select the intersection of construction lines in this way. And there is a mode of automatic input and creation of graphic lines. Choosing this mode, you simply click left mouse button and you automatically create lines between the two nearest construction lines. This way you do the input. Editing such a sketch is done by simply selecting the graphic lines, then you select one of the points, for example, the right one, and in this way you can re-snap the graphic line. Select again and attach the required location. When working with construction and graphic lines, it is necessary to take into account and remember that object snapping is always enabled. In addition, graphic lines have a free entry mode. If it is active, then the construction is performed simply in the free drawing mode, without being attached to anything. To turn off this mode, press the option again. Let's cancel the construction and continue the lesson. The base of the 3D profile has been created, we just need to choose the trimming of the construction lines. You can always restore construction lines with a dedicated command. In addition, it is worth remembering that there is an option that allows you to change the display of the thickness of the workplane sketch. We can display the sketch thickness in always 3 pixels, 1 pixel, actual thickness and no more than 3 pixels. After the base of the 3D profile is created, you can finish drawing on the workplane and see the result. If your 3D profile's base is closed, then the 3D profile will be displayed as a transparent filled object. If the 3D profile's base is open, then the 3D profile will be just an outline. That is, as a result of performing operations on such geometry, a surface body will be created. As a result of performing an operation on a closed 3D profile, a solid body will be created. Let's rotate the resulting 3D profile about a given axis. To do this, activate the rotation command. Let's choose a 3D profile. And in the Auto menu, use the Select Axis of Rotation option. In this case, the axis of rotation can be selected from one of the 3D profile edges. Click Finish Input and get a solid. The solid body automatically goes into the model tree, where it has a corresponding icon and rotation operation. Let's edit the 3D profile. To do this, open Rotation in the model tree, select the Edit Profile command with right mouse button and again go to the work plane where the base of the 3D profile was created. To complete the subsequent steps, we need a 3D node at this location. To do this, call the command from the ribbon and create a 3D node at the intersection of two construction lines and complete the input. We have a 3D node in the scene. It also appears in the model tree. We will need it for the subsequent snapping of the prism primitive, which will be created in the next step. To create a protrusion on a hexagonal flange, use the primitive command. We need the primitive prism. In order to snap this primitive to the already created geometry, you need to move the mouse cursor over the Z-axis, click and release the cursor. After that, you need to snap it to the 3D node with another click. You need to click on the height manipulator and release the mouse. After that, the value entry window is activated and you need to enter the value 11.2. Similarly, select the diameter manipulator and enter a value of 24. Use the mouse wheel to zoom in on the 3D model. This completes the creation of the primitive. Leave the command with right mouse button. Now on the resulting primitive you need to create a bevel. Note that at this stage there are two separate bodies in the model tree. In the future, we will combine them. To create a bevel, we need another primitive called a cone. But for this we need to perform additional constructions. Create a 3D node in the center of the specified face. To do this, select the face with the right mouse button. Immediately draw two mutually perpendicular straight lines in the center and create a 3D node. Trim the construction lines and click the Exit button. So, we have another 3D node in the scene. Calling the cone command in the ribbon. We can expand the model tree. We need it here in order to hide the second body in this way. Now we see the first node and the second node. Attach a cone just like a prism. Click on the Z-axis, it is blue, and release the mouse. Now our cone follows the mouse cursor. Select a 3D node. Select the height manipulator and snap it to the second 3D node like this. Now we can show the previously created prism. After that, we can select the diameter manipulator and snap to any middle edge of the previously created prism. It remains to select the angle manipulator and enter the value of 60 degrees. Now, to construct a bevel, we need to perform the Boolean operation intersection the prism and the cone being created. This can be done directly in the context of the running command. To do this, move the mouse to a Boolean operation, press and hold. It is important that you hold the mouse down for the menu to open. Then select the intersection command. Select the body you want to intersect with. In this case it is a prism and click Finish Input. Now we can leave the command and see the result. Bevels appear on the prism. Now we can combine the two bodies. To do this, we need a Boolean operation, which allows us to combine, subtract bodies, and create intersections. The addition operation is enabled by default. Select body 1 and 2. Bodies can be selected both in the scene and in the model tree. Then confirm the entry. One body appeared in the tree, which also consists of a Boolean operation, which includes a prism and a cone. Let's roll back this action to see another way to create a Boolean operation. You need to select the body, in this case, body 2, hover the mouse, press left mouse button, hold and drag and drop on body 1. Thus, you create a Boolean addition operation. Now let's create the lugs on the resulting body. To do this, using right mouse button, select a circular face and construct two mutually perpendicular lines in the center of this face. Any command, in this case line, can be called from the dynamic toolbar. To do this, select, for example, a vertical line and select Construct Line. The command for creating a line will be launched automatically and a vertical line will be created from the selected line. We just have to enter the value 15.25. Select the horizontal line and enter the same value. Let's choose the center and the intersection of the two created lines. We will need this construction in the future. Run the circle command. Select the center of the plane and enter the value 27.2. Press enter. Select the intersection of two straight lines. Move the mouse to already created circle. As a result, automatic tangency will be created. When we stroke the resulting skeleton with graphic lines, we need a circle on the projection lines, therefore, along the specified projection line, we also need to create a circle. We are now in the circle command mode, so just click on this graphic line. It is worth noting here that when drawing on a face, projection lines of this face, the contours of this face are automatically created. They are purple by default. This means that these lines are auxiliary, i.e. 3D profile will not be created based on them. Accordingly, they cannot be edited either. If necessary to create a 3D profile directly along the specified projection lines, it is enough to hover the mouse cursor with right mouse button, select this line and clear the auxiliary flag. The line will turn black. Now, if we finish drawing on the workplane, then a 3D profile will be automatically created along the specified graphic line. We don't need to do that, so return the lines to auxiliary type. Let's continue creating the skeleton. Choose the line command. Select the indicated circle using left mouse button. Our line will, as it were, run around this circle. With the second click, select the previously created line. We need it to set the angle and enter the value -18. Without leaving the command for constructing the auxiliary line, activate the special option Axis of Symmetry Creation. To do this, select the axis of symmetry and create a similar symmetric straight line relative to it. After that, leave the command by clicking the right mouse button. The resulting skeleton can now be stroked. To do this, activate the graphic line command. Turn the auto draw graphic lines between construction lines and stroke the resulting skeleton step by step in this way. A total of 4 such lugs should be created. To do this, let's create an array of them right on the workplane. Select the graphic lines twice in the filter toolbar. Then we can select only the graphic lines on the workplane. Position the cursor as shown on the screen and from left to right select the graphic lines in this way. After that, click by right mouse button on any graphic line, select the array command, type, circular. After that, we just need to select the center of the workplane to create a circular array. The array is created. In order to edit this array, for example, you want to edit the number of copies, then you can select any of the copies, select the circular array command in the context menu and select Edit Copy. After that, you can, for example, change the number of copies. Press Finish Input. In this case, it turned out to be 6. Let's roll back this action, because we only need 4 copies. After creating the array, do not forget to be sure to completely turn on the filter toolbar so that the next drawing on the workplane you have all objects active. This is done by clicking on the indicated button. The sketch is ready, you can finish drawing on the workplane. To create the lugs, we need the extrusion command. It can be called, for example, from the ribbon or simply using left mouse button. Select a 3D profile and select the extrusion command in the dynamic toolbar. Here, enter a value of 6 and reverse the direction of the extrusion. The extrusion result needs to be merged with the created body. To do this, press and hold right mouse button to display the menu. Select the addition point, then select the body with which you want to combine the result. Confirm the entry. After that, you can leave the command by pressing right mouse button. This is how we created the flange. Now we need to create a hole on it. The resulting profile can be hidden. You can select it directly in the 3D scene with left mouse button and press the hide button. A 3D node is required to create a hole. To do this, select the previously created 3D profile in the model tree. Go to the command for editing this profile and create a 3D node at the specified location. You can also create a detail at the stage of creating the sketch itself. In the lessons, this sequence is saved so that the user, while learning, can repeat these steps to edit the profile several times. This way we have created a 3D node. We finished drawing on the workplane, a 3D node has appeared in the scene. To create a hole, select the hole operation in ribbon. Specify the type of hole, with a chamfer like this. In the indicated window, enter the value 0.5. Enter the diameter equal to 6. Next, indicate the created 3D node and complete the input by double-clicking. As it was described in the previous lessons, the input can be confirmed either by clicking on the green checkmark, or simply by double-clicking on the free space, as in this case. This way we have created a hole on the body. We only need 4 holes. Accordingly, we will use the hole array command. Select the command array, circular. We need in this case array of faces. When you click on a face, the system automatically selects all faces that were created with the hole operation. After that, only the axis remains to be specified. The axis will be defined by 2 3D nodes. Let's hide the created body. We see 3D nodes. Select the first node and the second node. Show the body and leave the number of copies 4. This is how we can increase them. Then we complete the input. 4 holes appear on the body for the fastener. Let's create a threaded hole. To do this, select the appropriate type and indicate the tapered pipe thread. Thread height 16 mm. Hole, 3/8. After that, select the previously created 3D node and complete the input with a double click. Thus, we have created a threaded tapered hole. Now let's create a chamfer. To do this, select the blend command. Select the type, chamfer, length angle, and enter the length value 0.5. Then we need to select successively the edges on which it is necessary to create a chamfer. The edges are manipulated. This is necessary when a large number of edges are selected. To keep the manipulators out of the way, you can turn them off. Then, one by one, left mouse button select the edges on which you want to create a chamfer. Then the manipulators can be turned on and complete the input with a double click. In this lesson, we only have to design this part, that is, all the geometry at this stage is completely created. For the design, we will use the Materials window. The Materials window is called from a special window menu. Or the material icon is called in the ribbon 3D model. A window appears. Next, we need a material, steel cast. In the search, enter the name and press enter. Here we got the material cast steel. We want to apply it to the whole body. To do this, in the filters, double-click on the selection of operations to activate only operations. And then, move the mouse, hold down left mouse button and drag the material onto the selected body. Here we have got such a body. Now we need to adjust the texture of the material. The material was automatically copied to the model material. Select this material and click the Properties button. Go to the Texture section and change the texture value to 10. Click OK. The texture has taken on the desired look. Don't forget to turn the filter toolbar back on. The last design operation remains, the applying of materials, which allows you to paint the faces in the specified colors or apply the selected materials to them. Let's start this operation. We have a default material available, steel polished. We will use it to paint the selected faces. Select the blend faces, the faces of the created hole and the holes for fasteners. In addition, we will select the end surface, as well as all the faces obtained by blending. If you mistakenly selected the wrong face, you can undo the changes by right-clicking, or by selecting the desired face in the Properties window and pressing the minus sign to remove it from the general list of faces. All faces are selected. Complete the input with a double click. The Materials window can be closed. Use the Hide Construction button to hide all construction elements. To make the model look more presentable, you can change the quality of its display in the scene, for example, ultra fine. The model is ready, it only remains to save it.